This is the video solution to equipotential lines, example number 5. So what is the direction of the E field? Alright, so if I'm looking at this, there are a couple ways of finding out the direction of the E field, and that's why this problem is stated the way it is. So you can see all the different ways we use to find the direction of the E field. For question A, I know the E field points in the direction of the lowest potential. So it goes from 5 volts on the left to 2.5 volts on the right, so the E field would go to from left to right. For part B, it goes from negative 2.5 to negative 10. Negative 10 is lower than negative 2.5, so it's going to go downwards. For part C, I can look at the equipotential, the potentials as getting more negative the closer they get to C. I can also reason out that the E field is the path a positive particle would take. So a positive particle would be attracted to C. And for D, a positive particle would be repelled from C. Or I can also look at it as the way the E field will be the strongest positive value close to the positive charge, and the E field will get weaker as I move far away. So my rule still works. For E, I've got a potential going from 0 to negative 20. Negative 20 is lower than 0, so it's going from right to left. And for F, 20 is a lower potential than 50, so it's going to go to the lower left. And for G, well, if I look at G, this is our schematic diagram where the two vertical lines next to the G are actually metal plates or equipotential surfaces. And on my battery, I know that the long side is positive and the short side of the battery is negative. So in this case, the right plate will be positive and the left plate will be negative. So a positive charge will be repelled from the positive and go to the negative. So it'll go from right to left for the E field.